Those of you know that I've had a lot of sort of hassle trying to repair the original Hp4261a that I originally had. Couldn't find the fault, gave up with it in the end. I've left it on the back of the workshop and bought a second unit from my previous video, as you see, that was supposed to be non-working, that actually worked. And what that's allowed me to do is actually swap boards out and try and narrow down the fault to where the fault is, which I've done, thankfully, and it's been a great relief of my mind, because I hate having stuff in the workshop not working. I hate to be beaten by stuff like this, and I feel like I've cheated a bit, really, because I've just been swapping boards in and out of things to try and work out what's wrong and what's right, and what's trying to find the fault. Anyway, what it boiled down to is I tracked it down to when I went through the boards all the way through to the processor boards and all the various boards, and I got to two boards I tracked it down to. One of the boards was this board here. This is board number 6, and this sort of does a lot of the processing and things like this. When I took this board out and replaced it with the working one in the good unit, the unit automatically started to range better. The ranging seemed to work correctly, and also I got full control over resistance. The resistance measurements were accurate, which is the first time it's ever done that. And the ranging, auto ranging, worked straight away, jumped straight away to the right range, and when you changed the resistor it moved up to the range and then dropped down again. Everything was working perfectly in resistance, but I still couldn't get capacitance, and inductance still weren't working. So I thought, well, okay, so first of all I've got to do is track down the fault with this unit. And I've been through all these boards before. I don't know if these are listed in my videos, but I've gone through all these all these boards before. Now, this unit uses obviously TTL logic mainly, but it also uses a lot of JFET stuff. I don't know if you're any experience with JFETs, but they're really awkward, pain in the arse things to check when they're in the circuit, because a JFET, unlike a normal transistor, a JFET is basically on all the time. There's no voltage to the gate of the transistor, so it looks like every single transistor's got a short. So you go through and you think you're looking for a source drain resistance of probably 50-60 ohms, something like that, and you should have sort of like a couple of hundred ohms to the gate, to the source and the drain. Basically the source and the drain are one piece of silicon, so they're the same, basically the same piece of silicon, so the source and the drain doesn't really matter which way you get them round. It's basically a true electronic switch, bidirectional electronic switch. A little bit like a triac, I suppose, but they don't latch. And of course they're on when they have no voltage to them. Anyway, so what I started doing was I was thinking, well, I'm not going to replace any of the chips. You can see here at the first attempt I changed these two chips because I thought it was a problem with this board. Changed these two chips that I thought it was. Made no difference at all. So I started going through all the FETs last night, or the night before it was, checking for the shorts and things again. After I did all the obvious things like the diodes and obvious visual inspections, I actually checked all these capacitors to see if any of them are short or leaky, and they're all fine. So I started going through the transistors, and I came across, now which one was it I changed? Just trying to work out which one it was now. One of these transistors here, that's this one up at the top, isn't it? That's the one there. This transistor here, when I put it against the transistor tester, it showed, all these others were showing JFET, but this one was showing short. So I took it out and checked it again, and sure enough, there was a short circuit between the gate, source and drain. Now in circuit it looked almost exactly the same as all the others, and obviously I missed it last time. So I just put a normal JFET back in there, plugged the board back in, and straight away the ranging was working correctly, so that board was fixed. Brilliant. So that's one fault down. There's sort of getting a bit of progress. You picks your spirits up a bit when you're actually making some headway with the thing. So we did that and changed that, and that all seemed to work fine. So I thought, well, all I've got to do now is fix the capacitance range. Now the capacitance and the inductance range work on phase shifting. There's a couple of boards that are in control of that. One of them is this board 8, which I swapped out. Made no difference at all. I tried, so I went to board 7, and I thought it's not going to be board 7. Swapped board 7 out, and straight away capacitance range worked, inductance range worked. I'm thinking, great. So I've got to try and find this bloody thing with 18 chips on it, 21 chips on it. So I thought, well, I'll go through the manual and see what the manual says. So you find board 7, this is A7 board. Got to A7 board, and it says for fault finding on this board, it says there's no fault finding information available. Please proceed to the next board level. So basically, what it wants to do is, it won't give you any logic or anything for this board. So what it's trying to do is checking all the other boards, and if all the other boards are okay, basically it means that this logic board is the one that's at fault. So okay, so what do you do now? I can't test any of the logic because I've got no extender board, so you can't get to anything on the boards, and you can see it's sort of like well, you just can't get to it. There's no room in the unit to get to it. So I thought, well, the best bet for me to try and do is try and get in contact with this seller again, this seller in China who wouldn't shift on his prices. So I thought I'll send him a message. So I sent him a message 2 nights ago and I said, look, I didn't say, I don't know if he remembered who I was from last time. I said, I'm interested in one of these boards. I'm only a hobbyist. I don't really want to be spending £50 on a board and then £25 shipping. Would you consider lowering the price? And I waited a day. Nothing happened. I thought he's not gonna respond. So what I did do is there were a couple of frequencies specified for these test points, and I went through all those and compared them with the working unit, and all the frequencies seemed to be correct. Apart from test point 5 seemed to sort of miss a pulse every now and then, and I sort of tracked it through the board, and it was a bit inconclusive. And then when I went back and tested it again, it all looked absolutely fine. So I was thinking, well, it's obviously there's something wrong on the board, and we knew that the sort of first fundamental frequencies available. This is the clock generator. This takes a 2.3 meg clock, and there's a couple of divide by 12 chips here. These were working fine. So basically I ascertained that probably all those top chips were working fine. So the stuff that seemed to be coming out of the board was wrong, and these are basically the chips at the bottom end. So I thought, well, maybe it's a case of just taking all the chips out and replacing them. So I went online and had a look on eBay. The price of some of these chips is like £2.50 each, you know. So that's sort of, well, to replace the board, you're going to talk about £2.55, £7.50, 10, 20, 30, 40, 50 quid to replace the chips on the board. So I'm thinking, don't want to do that really. So I thought I've got an account I've opened up with radio spares, which I've been meaning to do for ages, and I managed to find all these chips, and most of them are around sort of 60-70p each. I think one of them was £1.50, and I thought, well, let's just order some chips then, because they give you free delivery and turn up at work the next day. So I thought, well, what I'm going to do then is I'm going to start with the bottom row. I'll just shotgun the whole lot. So basically I cut all the legs off the chips, unsoldered them, cleaned all the board up, and piece by piece replacing the chips. So I replaced all the chips. Basically I did it last night. I was waiting for one chip I hadn't ordered, so I did all that, and I thought, well, that's good, we're on our way. Meanwhile I get a reply from the chap in China saying, thank you for your message, you can have yes, you can have 4 boards for $140. I'm thinking, no, I don't really want 4 boards. I mean, 1 board would be nice. And I'm thinking, well, at least he's had the decency to reply, and he was giving me something like a 30% discount. So I thought, oh, you know, I'll try again. I said, look, I don't want 4 boards. I'm only repairing 1 unit. I said, does that 30% discount cover for just 1 board? And then there's that pregnant pause of a day. So meanwhile, I would get the chip back, get the last chip in, resolder it all in, and I plugged it into the unit this evening. And as you can see from the original video, everything's working. It's all working fine. The unit's powered up. The capacitance range is working. It's not doing its thing of hunting through the capacitance range. So after a year of sort of sitting on the back shelf, the unit's finally working. In the meantime, the chap got back to me from China and said, yeah, you can have a board for, I think it was about 20 quid. And I'm thinking, well, that's a bit more reasonable, 23 quid I think it was. plus the 12, 15 quid postage. So, alright, I repaired the board, and I'm thinking, I wish I hadn't asked him for the spare board, but I've actually ordered this board, so I've got a spare board coming for it now. You never know if the other one's going to fail. But obviously this one's working, and what I want to do this evening is actually run it quickly through a calibration. I've done the voltage on the power supply, and I have gone through calibration on this before, but of course as the chip's been replaced, or some of the chips have been replaced, it might affect the performance slightly. It does actually seem to be performing very well. Its capacitance seems to read exactly the same as the other one, and to a known good standard at work. So I think really it's basically ready to go. But I think I'll just run through a couple of capacitance calibration just to see what it's like. So the first calibration is on the A4 board, and all these boards are marked with yellow or well, various colour. Just bring you up so you can see what's going inside the unit easier. Different colour boards. Now you can see here, this yellow one's broken off here, but these are all identified by the board numbers. So what I'm going to do is I'm just going to go through and do a calibration. It might be useful to someone, well I hope it will be, and then we'll just see at the end result what it's like. So the first test is as follows. It says connect the BNC alligator clip to the test point 3 of the board 4. So test point 3, use a torch to see what we're doing. So test point 3 is this one, and it says you've got to set the various controls to 1 kilohertz. That's going to be off. That's going to be 1 volt. Internal, capacitance, parallel, and that's got to be off. And connect nothing to the unknown terminals. In other words, open circuit the unknown terminals. Okay. And it says set the oscilloscope to 5 millivolts per division, sweet speed to half a millisecond. So let's go up to the scope. You can see that. Zoom in a bit so you can see. Okay. So half a microvolt. Oh, 5 microvolts. Let's go the right way. There's your 5 microvolts. And what was the time base? The time base was half a millisecond. Okay, it's half a millisecond. And it says set the input scope to ground. So we put that to ground, and then we bring our pointer to a center graphical like that. And then it says yes, adjust the position of the oscilloscope so the baseline is in the center of the CRT. Set the oscilloscope trigger mode to automatic. It is set oscilloscope input mode to DC. Okay, it is DC. Adjust A4's R87 offset until the DC is displayed within 0 millivolts plus or minus 2 millivolts. So basically what we're looking for is the DC level to not shift where we go from DC to ground, and it doesn't. So that point's set correctly, and that's just a DC offset adjustment, and most of these could up and coming settings are the same. And it says click the high and low terminals together. So what I'm going to do is short these two together, so I'll get a jumper lead for that. So what I'm doing now is I'm shorting the jumper lead out on the short these two together. DC bias is off, 1 volt, internal, serial, range hold is off. Yeah, short the 4 unknown terminals together. Well, I am shorting the 4 unknown terminals because there's a link behind the back of these here, so they're all shorted together. Set the oscilloscope to, oh, basically the same range it was before. Set input mode of the oscilloscope to ground. Okay, you see a slight DC offset there. If you can't, because you're not looking at the scope. I can, but you can't. Here we go, let's have a look. So we're at a ground point now. Set the input of the scope to ground. Adjust the control to the centre of the screen, which it is by my viewing here. Unfortunately, the backlight for the graphical isn't very good. Set the mode to DC. Okay, so very slight, hardly noticeable actually. So I don't think I'm going to be able to get that any better than that. So basically that's another adjustment, and then you just R31 to get the centre line. So we could just have a little tweak so we can get that any better. So R31, which is, I think that one there. That's offset 1, I think it is that right? Yes, offset 1, this is offset 1 pot. So if you look at the scope now, you'll see that the DC offset's changing. So what if it was out of calibration or it was out of balance? There's your DC point. When you go to, that's your ground point. When you go to DC, it shifts, so we need to keep that right in the centre, so there's no change in position. Now that noise on there, you can't do anything about that, but what you basically want is, you don't want to shift in position. Let's turn the volts per division up to maximum actually. Ground it. Bring it back down central again, so let's go DC. So that's spot on. So okay, that's that first offset control done. Offset 2 adjustment. Connect BNC to alligator clip to the test point 2. It does go a bit long-winded, these tests. They sort of go through everything again. It's pretty obvious if you're doing test point 2, you just move the clip to test point 2. You don't need to be told how to do it. But anyway, we've adjusted to offset adjustment 2. This is connect the BNC alligator clips between, yeah. Function is C mode, yep, and then we're in parallel. Connect nothing to the unknown terminals. Okay, remove that. Now then, let's come back to here a minute. This is adjust R40 offset 2, which is this pot here. For the same thing, for 0 offset on the scope. It's fractionally, very fractionally high, but I mean the pot's so, been a bit of contact cleaner in that pot. It's a little bit noisy maybe. I can't bring you back up to the scope. Unfortunately I don't think I can really get the scope and the meter in at the same time. Now I've adjusted this so it's going to be miles off. So there's your DC point. There we are, just there. And this is only very sensitive range now. 2 millivolts per division. That's fine. Excellent. So that's test point offset 2 done. Let's go to offset 3. Set the level to 50 millivolts on the front panel of the signal generator. So I've got to 50 millivolts on this switch here. Set the oscilloscope to exactly the same as it was before, so I don't know why it keeps telling me. Let's change it to 5 millivolts when it was on 5 millivolts before, wasn't it? Not that it makes any difference, I just think you want the maximum sensitivity you can. I mean, really, you don't need to be told what oscilloscope setting to have, you should be able to work it out yourself. And it says adjust R54 for 0 offset, but it does say the waveform will be noisy. Well, it's not joking there, because I'm actually, there's the noise on the waveform. You can see it jumping around. Now, just checking, because that's always what you get. That's exactly the same reading I got before, but I just want to check to make sure I'm not doing anything wrong. test point 3. It hasn't told me to short anything out or. So we're not interested in the sine wave, we're interested in the shift in the position of the offset, like all of the previous results. And you can see it is possibly slightly shifting, but you have got an AC component on there anyway, a bit of a low frequency ripple. So ground that again a bit. Yes, that is shifting slightly. So I'm going to adjust offset 3, which is this one here. I don't know what you can see that's like on the scope, because you might get some aliasing, but okay, it looks reasonably on the screen of the. So that's a ground point. Yeah, so that's good. That's fine. So that adjustment's spot on as well. And then it says. Doesn't say anything about offset 4 pot. So you leave offset 4 pot, I think. Nothing's mentioned about offset 3. Yeah, stops at offset 3. I think you go back and do something with offset 4 afterwards. So A6 board is next. So we're going on to the A6 board down here. So let's have a look. A6 board. So we want 1 kilohertz off, 1 volt internal inductor, serial off. Short unknown terminals together. Done. It says set the slide switch on the A6 sequential control board assembly to position 2. Now that's this switch up here. There's a selector switch here for various fault diagnosis modes. Switch position 2 is on. I don't know if you can hear it, but it's actually cycling through different ranges at the moment. Set the range hold to on at any time. So basically just what we're doing now is we're taking the range hold on. You can see it cycling through its ranges. This is a sort of part of the self-diagnostic thing. And then a range hold, just hold it in range. Okay. So set offset 4 on R5. Okay, let's get this right. Set offset 4 potentiometer on A5R85, which is offset 4, which is this one, to midpoint position, which it is, and that was from the last time I tried to set it up when it failed. Okay, adjust 0 offset A6R68. Doesn't actually tell me. Am I supposed to put this on a test point yet? Oh, test point 2. No, hold on a minute. Just. Oh, okay. I don't need the scope at the moment. What I need to do is. I've got to. All I need is to display that. That's correct. It says stop it at any point, but if you stop it when it's not on one of the ranges, it doesn't. Excuse me. It doesn't display anything. It says adjust 0 offset R68 for 1000 plus 0 counts. It's 1000 spot on. Adjust the phase offset for 0 counts on the dissipation factor when it's at -0. I think I'll just bring that up slightly, so that's R67, which is the phase one, which is this pot here from memory. I should know, I've done it enough times. So let's get that to 0, as close as I can. Basically this thing hasn't the changing of the chips hasn't made any difference to the calibration, or the repairing of the boards hasn't made any difference to the calibration. So that's a 0. Reset A switch to its normal position. It's done. And now it says set the unit to capacitor parallel, engine control off, and it says connect to a 10 nanofarad standard capacitor. Well, I haven't got 10 nanofarads, but I have somewhere got a known value capacitor that was tested at work. There is about, I think it was about 18 nanofarads. Where is it? It's here somewhere. I was using it just a minute ago. Ah, I see it. Okay. Right, I am going to use leads, but I'm going to keep them separated apart to try and reduce any capacitance. And it says you connect this up now. I know this is 14.9 nanofarads. Well, there you go. 14.89. I'll set it to 14.9 just to be. And it's the adjustment here is, yes, it says connect to 10 nanofarad standard capacitors, the unknown terminals. Standard capacitor 10 nanofarad using step 1 and a resistor 100k in step M are listed, and it's just basically how to set up, check the resistance range. Well, the resistance range is right, I don't need to adjust that. Carefully adjust the phase offset A6R67 so the D displays shows calibrated D value. Now the D value is the dissipation value, and I think I checked that at work, and I think I got it here as 0.3, 0.03, and you've got it 0.04. So that's it. That completes the calibration on the unit. There is, what's the final test? Is there? It's basically a confirmation check of trying different value capacitors just to make sure the auto ranging works correctly. And I'll quickly demonstrate that now. But this is a 0.47 non-electrolytic. Beautiful. Goes straight round to the range. No problem. This is basically power factor. This is a different word for power factor. I think basically the lower the figure, the better power factor. Resistance, I'm not sure you can use it for resistance. I'm not sure how it copes with. Let's put it into series mode. Okay. This is what the other one does. When you're trying to measure ESR, like if I'm assuming it's putting an AC frequency through the capacitor. Let's try higher frequency. It struggles with its range control, but it does show that it's got about an ESR of about 3 ohms. So it sounds about right, probably at that frequency. I expect it to be much higher than that at lower frequency. Yeah, but it says 17 ohms. It's a bit flaky for sort of doing ESR with this because it doesn't seem to, the range doesn't seem to settle properly. But certainly a dissipation factor gives you a good idea of the quality of the capacitor. And it all seems to be working absolutely fine. So thanks for watching. That wraps it up for these LCR meters. I've got someone at work who's interested in buying this one, which is nice, and hopefully the other one will last a good couple of years. Thanks for watching.